Here is a rational equation. Rational equation meaning it's an equation containing fractions. This is problem 52 from Review 6. Remember, when we have a rational equation containing fractions, we want to find a multiplier that when we would multiply it through, it would cancel all the denominators. We want to create a new equation that is free of fractions. The way we can determine what that multiplier is to first start by factoring any of the denominators that are not completely factored. X plus 1, x plus 2, completely factored. What I would really hope for is that x plus 1 and x plus 2 were factors of that trinomial. Let's see if they are. Let's put them down and see. Well, plus 1 times plus 2 is going to give us plus 2 under the L of FOIL. O of FOIL, plus 2x. I of FOIL, plus 1x. Those two terms combine to plus 3x. In order to cancel this fraction, this denominator, this fraction would have to be multiplied by those two binomials so that they could cancel the binomials that are there in the denominator. So I want to multiply this side of the equation by the pair of binomials x plus 1, x plus 2. And if I were to multiply this side of the equation, which I must do, I have to multiply both sides of the equation by the same quantity or I destroy the equation. Likewise, I would be able to cancel both of the denominators of these fractions. When I multiply this first fraction by those two binomials, the x plus 1's cancel, leaving me x plus 2, that binomial to be multiplied by the binomial x plus 5. Multiplying here, the x plus 2's cancel to 1, leaving in the numerator here x to be multiplied times the binomial x plus 1. And here, there's complete cancelization. Cancelization? How about cancellation? The binomials here cancel the denominator completely, simply leaving me the numerator 4x plus 1. And now I have a new equation to solve that is completely free of fractions. We need to get rid of those parentheses first in order to see exactly what kind of equation we have. Binomial times binomial will require us to use FOIL. The f of FOIL would give us x squared. Plus 5x plus 2x more is plus 7x for the O and the I of FOIL. Plus 10 for the L of FOIL. Minus x squared minus x when we multiply through with that set of parentheses equals 4x plus 1. Oh, that's nice. The x squareds cancel, leaving me simply a linear equation. 7x minus x, that's 6x. When I combine the like terms that are on that side of the equation, subtracting 4x from both sides, 2x plus 10 equals 1. Subtracting 10 from both sides, I get 2x equals negative 9, x equals negative 9 halves. The solution to this equation is x equals negative 9 halves. Remember, when the variable appears in the denominator, we have to be concerned about the restrictions on the variable. Can't have 0 showing up in the denominator if we were to substitute our supposed solution in for x. Well, remember, what would be the restrictions here? What value would make the denominator become 0 here? That would be negative 1, wouldn't it? That's not my solution. The restriction here would be negative 2. Likewise, that's not what we found as our solution. So we don't have to be concerned that our solution we found was one of the restrictions. We would still have to test it, which we probably wouldn't want to do. Who wants to plug negative 9 halves in for x into that mess? We'll just hope that we did things right, and that's the right answer. But that's our approach to solving equations like this. Find a multiplier, multiply through both sides of the equation to clear out the fractions, solve the resulting equation.